Hello Cretans, here Mr. G, and we're going to be doing another question related to physics in preparation for the paper one, okay? In this case, we're going to be doing a question on mechanical energy, right? So this question was taken from 2013 set B from the Northern Cape, and it was adapted. I didn't take everything, okay? Now this question say a boy let a stone fall from a cliff 150 meters high. The mass of the stone is 1.5 kilograms. And here you can see the cliff with the stone, and the stone is falling. This stone is moving. So let's draw an arrow here down and let's write moving. Okay, the stone is moving now. It's falling down. Now here it was dropped. So the initial velocity, and that is important thing even before we carry on, the initial velocity or speed of this rock is going to be equal to 0. So it's not going to be moving at the beginning because it was dropped. That means drop, in this case he let the stone fall, he let fall. So the initial velocity is going to be 0, and we're going to need that one a little bit later. That is at the beginning, okay? Now what type of energy does the stone has at the top of the cliff? That is at this moment when the stone is going to start falling. And then obviously you have to explain why did you select that specific energy. Now calculate the energy referred in question 1.1. You have to calculate the energy you mentioned there. Then state the principle of conservation of mechanical energy. Explain what must be known to be able to apply the principle of conservation of mechanical energy, which was question 1.3, and 1.5. Calculate the kinetic energy of the stone just before it hits the ground. Alright, so now saying that, let's begin with the question 1.1. What type of energy does the stone have at the top of the cliff? And explain your answer. Now, in this case, we have two main types of energy with it. Okay? And those energies were gravitational potential energy and kinetic energy. So, what is gravitational potential energy? The gravitational potential energy is the energy an object has because of its position in the gravitational field relative to some reference point. Okay, so this is the gravitational potential energy. Note, these are not the only potential energy there is more, but we're only doing gravitational potential energy. And so because we're doing only this one, the symbol we are going to use is EP. Okay, now sometimes in some books here at school you will find the symbol U. It does not really matter which symbol you do. Okay, that is the symbol for potential energy or gravitational potential energy, and this is going to be equal to mgh. So this is the formula that we are going to use for the gravitational potential energy, and the unit of the gravitational potential energy is the joules, and the symbol is a J. So we have in that potential energy is the energy an object have due to its position in the gravitational field relative to some reference point. And now, what is kinetic energy? Now, kinetic energy is the energy an object has due to its motion. So every time an object moves, it has kinetic energy. The symbol for kinetic energy is going to be EK, and this is equal to half multiplied by the mass of that object multiplied by the speed of the object to the power 2. And the unit for this one is again going to be the joules. Okay, so this is the other energy we learn in class. Now there is one last, which is mechanical energy. Now mechanical energy relate the kinetic and the potential. Okay, so mechanical energy is the sum of potential energy and kinetic energy. The symbol for mechanical energy is going to be EM, and this is going to be equal to kinetic energy plus potential energy. Alright, so this is the energies we done. Now going back to the question said what type of energy does the stone has at the top of the cliff. Now they're referring at either kinetic or potential. Now the top of the cliff here, note that the object is not moving, and therefore it cannot have kinetic energy. But the object is a certain height, so the energy that the object has is gravitational potential energy. So this is 1.1. The type of energy that the object has is gravitational potential energy, and it's because it has a high certain position relative to some reference point. In this case will be the ground, and it is on the gravitational field. So that is the gravitational, the energy that the object has at the top of the cliff. Okay, now in 1.2 they say calculate that energy. So here is the formula. Here is the formula. We're going to apply to use that formula to calculate the gravitational potential energy at the top of the cliff. So here we are by 1.2, and now potential energy is equal to the product of mass, acceleration due to gravity, height. The mass is 1,5 kilograms. We are near the surface of the Earth, so the acceleration due to gravity will be 9,8, and the height is 150 meters. So when you do this calculation, you get 2,205 joules. This is the question 1.2, very simple. Now, question 1.3. Question 1.3 state the principle of conservation of mechanical energy. Okay, so now let's state the principle of conservation of mechanical energy. Now, the principle of conservation of mechanical energy states that the total mechanical energy in a closed or isolated system remains constant. Now, closed and isolated is not exactly the same, but we are not going to be looking at that terms right now. Eventually, when you are in grade 12, we can look more details though at the different types of systems. Okay, so the total mechanical energy in a closed system remains constant. Now, this closed system, this means that there are not external forces. So the net external forces is equal to 0. Just for you to understand, there won't be any friction. So if there is friction, then this principle, this law cannot be applied, right? So, and that is the next question. The next question said, is asked here, explain what must be ignored to be able to apply the principle in question 1.3. Now, to apply this, they say the system must be closed. So there must not be friction. So what is going to be ignored here? The friction due to air. So there is air, but we are going to imagine that the air does not do any friction or doesn't affect the motion of this stone. So that would be the answer for 1.3. So question 1.4, sorry, that will be air friction or air resistance. It should be air resistance. Let's write air resistance, and then you can substitute friction. Air resistance, okay? That is what must be ignored, because there must not be any external forces acting on the system, okay? So I'm going to write air resistance, and in bracket I'm going to write friction, okay? So that is what must be ignored. So that is what must be ignored. Why? Why? Because the system must be closed. If there is friction, then the system is open. You can write it if you want. If there is air resistance, the system is not closed. And the final question is going to be the calculation of the kinetic energy at the bottom of the cliff. Remember, it's not when it's on the cliff, but it's when it's going to be almost in the cliff, when it's down there, okay? Alright, so here we are in 1.5. We have to calculate the kinetic energy of the stone when it's there, when it's just about to touch the ground. It's not after being on the ground. That is the question here. That is the question there, okay? So we are going to apply the principle of conservation of mechanical energy, right? So this system is closed, okay? You don't have to write closed system, but you can start by saying that the total mechanical energy initial is equal to the total mechanical energy final. You can start by that, and remember, mechanical energy, here is the formula, is kinetic plus potential. So everything on the left hand side is initial, so this is going to be the kinetic energy initial plus the potential energy initial is equal to kinetic energy final, and this is what they're looking for, plus the potential energy, let's fix that word in there, potential energy final, okay? So now here, kinetic energy initial will be half multiplied by mass multiplied by the initial speed square plus potential energy initial, but that one is given because we did calculate it. Potential energy initial is equal to kinetic energy final. That is what they're asking us to calculate. This is not an equal, this is a plus. I'm very sorry about that. Plus mass times acceleration due to gravity times the final height. Now, what is the initial speed of the object? Here it is the initial speed of the object is 0. Alright? So all this is going to be then 0. All this one here is going to be 0 because the initial speed is 0. So it's 0 plus the initial potential energy. It was calculated is 2205 joules is equal to kinetic energy final. That is what they're looking for. Plus, now note that the height at the bottom here, the height here is equal to 0. There is not height. So all this product here is going to be equal to 0. So plus 0. The final answer is that the kinetic energy final is equal to 2205 joules. That is the answer for this specific question. And this is all for now. Thank you for watching. I hope it helped. The question is not difficult. It's an important question for the upcoming exam. Please practice the question. I'll come later on with more videos on this topic or any other topic, and please, you can ask questions, you can suggest, you can ask me to make a specific video if you want to, and I'll try to do my best and make it for you. Thank you for watching. I hope it helped. Please thumb up and subscribe if you didn't. Thanks a lot.